All of you guess it which chapter, my children? Hello my dear students, this is P. Venkateshwarlu, PGT Physics. Today I will discuss about sound. Okay, so 9th class Physics lesson sound. In regular life, see everybody can experience this. I say, so I am saying lecture. Okay, so are you listening or not? Okay, you are listening. Something you listening means that is sound. Clear, my dear children? See, coming to the introduction of hearing, sight, smell, taste, and touch are the five senses we use to gather information about our surrounding. We hear when something reaches our ear. What is that something? That something is called sound. That something is called sound. Definition of sound. Okay, definition. My children, sound. The definition of sound means sound is a form of energy. Sound is a form of energy. Clear? Sound carry information, means sound carry energy and momentum. Sound wave can carry energy and momentum. Okay, so we can say sound is a form of energy. Sound can transport energy and momentum. So energy means sometimes energy we treat it as information. I am speaking. Means what? Sound energy can traveling from one point to another point. Clear, my children? Yes. So momentum. So momentum means here the particles of the medium vibrates. Okay, while we are talking or giving some sound, means the particle vibrates. Sound is a form of energy which creates some disturbance in the medium. Okay, so if sound can traveling one point to another point, means medium must have elastic nature, elastic and inertia. Medium must be elastic and inertia. That medium should have some inertia. Okay, so elastic means what? So consider 8. These are the 8 particles. Okay, so these are the 8 particles. When we speak, the particles vibrates. The particles vibrate to and fro or up and down. This we can say elastic. The medium should be elastic. And inertia, we know that inertia, the inability of a body, it will not change its position, its direction, its motion. We can say inertia. Sound waves can require medium to propagate. So in vacuum, sound will not travel. Okay, sound requires medium to propagate. Means, so in air sound wave can traveling. In liquids and solids. Okay, so here sound waves cannot traveling in vacuum. Okay, see here, sound waves cannot travel in vacuum. Okay, only which is passing air, liquid, solid. So vacuum means no medium. In vacuum there is no medium. Means here, that's why we call it sound waves. Sound waves we call it mechanical waves. Mechanical. We know the definition of sound. Clear? So how we can get the sound? How we can produce sound? Okay, here very important point is how we can produce sound means vibrating bodies. Vibrating bodies produces sound. Okay, how we can get the sound? Vibrating bodies are produced sound. If anything vibrates, sound will generate. In regular life, we have to observe many times in our home, so in other places, in outside of the house, we are hearing some sounds due to vibration. Vibrating body produces sound. Consider a tuning fork. It is tuning fork. Okay, so sound instruments. Here these two are called prongs. Okay, here we can say stem. Okay, this entire we can say tuning fork. So whenever by using rubber hammer we can apply the force here, means this is rubber hammer. By using this we have to force applied here. The body vibrates. This stem, by using stem we have to place near the ear, we can get the sound. Clear? The same thing which is taken on the water surface by using one water beaker like this. So here the level of the water will changes, means some disturbance we can observe. Remaining information I will explain based on the PPT. Clear? So using some pictures, some animation. Can you hear or observing anything here? Coming to the content, at the end of this lesson, you will be able to define sound, explain how sound is produced, explain how sound propagates from the source to the listener, demonstrate that sound needs a medium to travel, compare longitudinal and transverse waves, identify the main characteristics of the sound wave, compare speed of sound in different mediums. Coming to definition of sound, sound is a form of energy that produces a sensation of hearing in our ear. Sound is a form of energy. How we can verify? Yes, verifying that sound is a form of energy. In this case, we have to take one tin can, removing base and lid, and we are using membrane, we are closing, and with the help of rubber band. Yes, like this. So with the help of rubber band, we can create one membrane. Membrane something which vibrates. So we are attached one mirror. So and we are considering one laser beam or laser light. And we are focusing wall. When laser beam falls on the mirror, laser light reflect towards the wall. Whenever we speak or we make sound with our mouth, so that mirror will deflects and we can observe the path of laser beam will changes. See here, this is the arrangement. When we make sound, the beam will deflected. When we make sound, the vibrations occur in the membrane. While vibrating the membrane, the path of laser beam will changes. Means mirror also changes small moment. Means by vibrating, the path will change. It means sound created some disturbance. Can you observe here this sound? Yes. And one more sound here. In this case, we can say vibrating body produces sound. Vibration means to and fro motion of a small string. Fast vibration means to and fro oscillation is very fast. Here you can observe. Means what, my children? Yes, to and fro movement, up and down, horizontal and vertical, to and fro motion or up and down motion, we can say vibration. Which is slow means we can say oscillation, which is fast means vibration. Here you can observe easily. And vibration, this we can say fast. Clear? How we can verify vibrating body produces sound? Yeah, by observing this, you can say vibrating body produces sound. Intensity of sound. The amount of sound energy incident per unit time per unit area, we can say intensity of sound. SI units of intensity of sound, watt per meter square, power per unit area. Clear? Propagation of sound, you can observe here from source to listener. Sound propagate through a medium. Medium is the matter through which the sound is transferred. Propagation of sound in particular mediums, liquid, solid medium and gaseous medium. How does the sound travel? How sound can travel from one point to another point, otherwise from the disturbance created to our ear, or from the source of sound to our ear. What happens when we cause a vibration to produce sound? So consider a rubber band, elongate and touch it by applying force. So here you can observe some vibrations. Okay, how they can travel, some like waves. So the type of waves we can say longitudinal waves. So their particles movement is more, later less. So at the where the sound is created, we can observe the particle motion like this, maximum and minimum. Somewhere particle density is more, somewhere particle density is less. So sound waves are best examples of longitudinal waves. In the longitudinal waves, the mode of vibration of the particle in the direction of wave propagation. See, these are the this we can say examples of longitudinal waves. See, sometimes the particle density more, sometimes particle density is less. We can say compression and rarefaction. Where the particle density is more, we can say compression. Where the particle density is less, we can say rarefaction. Coming to definition of wave. A wave is a disturbance that move through a medium when the particles of the medium set into neighboring particles into vibration. See, you observe some vibrations here. Consider a tuning fork having prongs and base stand. We can say that is tuning fork. With the help of rubber hammer, we are applying force on the one prong. Here we can observe some vibrations. The two prongs are vibrate from the mean position. Clear? Later which comes rest. After applying force, they are vibration from the main position. Clear? Here we can produce as longitudinal waves. These two are vibrates from the main position. While vibrating, we can observe like that particle density is more and particle density is less. We can say particle density is more, we can say compression, high pressure, where we can get the high pressure or high density region. While we are talking, we can get the type of situation. Particle density is more, particle density is less. We can say particle density is less, we can say low pressure, rarefaction. We call it rarefaction. Clear, my children? Compression, rarefaction. When we are talking to one to another, the medium between person to person, the particles, they are move like this, they are vibrate like this. Compression, rarefaction. Because sound waves are longitudinal waves. Here the vibrations in the direction of propagation. Sound waves are mechanical waves, means which require medium. Sound waves require medium, we can say mechanical waves. Which doesn't require medium, we can say non-mechanical waves. Sound waves can travel in air, water, gases, like that. These mechanical waves can categorized by transverse and longitudinal. Here transverse waves, sinusoidal function. Here these two types of waves, transverse waves and longitudinal waves. Sound waves in air or longitudinal waves. Coming to transverse waves. The particle of the medium vibrates up and down about their main position in the direction of perpendicular to the direction of wave propagation. Here we can observe up and down vibration, and wave is moving forward direction. This we can say transverse waves. Vibration is up and down, but propagation is perpendicular to the vibration. When we throw a stone on the water surface, we can observe transverse waves. Okay, pond waves, we call it sometimes pond waves. So when we can throw any on the water surface, some disturbance occur, we can create waves. So disturbing body produces some waves. Here we can observe transverse waves. Sound waves on the water surface, we can say transverse wave in nature. The vibration which from the main position. A peak in transverse waves is called crest, and similarly a valley is called trough. Coming to longitudinal waves. The direction of vibration of the particle in the medium is parallel to the direction of propagation of the wave. So here in this case, vibration and transfer of wave, propagation of wave direction is same. See here, horizontal vibration is there, and direction of the sound also, which is horizontal. We can say this type of waves, we can say longitudinal waves. Sound waves in air are longitudinal waves. Where the particle density is more, we can say compression. Where the particle density is less, rarefaction. Here in spring also we can observe particle density is more, compression. Particle density is less, rarefaction, means number of turns. Coming to wavelength, my children. See, we can observe crust to trough or compression, rarefaction. How we can define wavelength? So wavelength means length of the wave. The distance between crust and crust, or trough and trough, or compression or rarefaction. The distance between compression to compression, we can say wavelength. The distance between two consecutive compressions or two consecutive rarefactions, we can say wavelength. Here in this case, the distance between one crust to another crust, one trough to another trough, we can say wavelength. Sound propagation is a periodic phenomenon. Time period is the interval between two successive compressions or two successive rarefactions. Periodic means the motion which repeats after particular time. We can say that periodic function or periodic motion. Here time period, how we can define? The time taken by one complete oscillation, one true and one pro. One true and one pro, we can say periodic motion of time period. Frequency, it is denoted n, which is defined as number of vibrations or the number of oscillations per unit time. We can say frequency. SI unit of frequency is hertz or second inverse. SI unit of time period is second. Clear, my children? Frequency, which is defined as the number of vibrations or the number of oscillations per unit time. The SI unit of frequency is hertz or second inverse. Clear, my children? There is a relation between time period and frequency. See here, the number of waves per unit time, per unit second, how we can observe waves can passing. The relation is frequency is equal to 1 by time period, Reciprocal of time period is called frequency, where t is the time period, n is the frequency. Here you can observe frequency is more, the number of oscillations per unit time. For less time, more frequency. These are called characteristics of sound. Coming to pitch and frequency. Clear? Here child can crying or making sound. We can say pitch is more. Here another one is the wavelength is more. We can say low pitch and high pitch. Here this bird make low pitch and children can make high pitch. High pitch means less wavelength. Low pitch means long wavelength, or we can treat it as loud. For unit length, we can observe number of crest, number of trough. We can say more pitch means less wavelength. The pitch is the interpretation of frequency of the sound by the brain. What is pitch? Pitch is the interpretation of frequency of sound by the brain. Wave shape for the high pitched sound and wave shape for low pitched sound. Here children are crying, we can say high pitch. Wave shape for low pitched sound, wavelength is more. Okay, wavelength is more. Frequency is less. Frequency is more. Means wavelength is very small. Coming to quality or timbre. How we can define quality or timbre? The difference of one to another sound, one instrument to another instrument, we can say quality or timbre. How you can differentiate one sound with another sound of instrument, we can say that is quality or timbre. Quality or timbre of a sound helps us differentiate that sound from another with the same pitch or loudness. Means here produces pitch or some loudness. We are differentiate one to another. So we are identify one to another sound with the same loudness, with the same pitch. Clear? We can differentiate easily. This we can say quality or timbre. You can observe this sound, violin, sitar, some musical instrument. We can differentiate one to another sound. We can say that is quality or timbre. How sitara making sound while vibrating. That is the difference between one to another. A tone is a sound wave of single frequency. We can observe many time tone. Clear? We observe many sounds which are regular and irregular sounds. Note, my dear children, a sound produced due to a blend of several frequencies. Okay, my dear children, until here today's session completed. If any doubts, ask me or text me. So all should attend Zoom and take attendance. While entering Zoom, you enter your initial name after section. So otherwise you can't get attendance. Attendance is more important. Clear, my children?